Okay, guys, today, inshallah, we're going to continue lesson 1 of chapter, which we're talking about the chemical reaction. We're still in chapter 12, talking about the chemical reaction. So, who can remind me what we studied last time? So, what we studied last time, guys? Who can remind me? Yes, Hana Hamdi?
Difference between the physical and the chemical
Yes,
property
okay, so that
chemistry.
wasn't the first session. Okay, so in the first session we know what the difference between physical and chemical change, then we know the signs of a chemical reaction. But yesterday we just talked about, who can tell me what we studied yesterday, guys? Let's find. Yes, Judy.
The equation
The chemical equation. Good. Last time we started
and
talking about chemical equation. Yes. So what
the
else?
equations will be
Coefficient and subscripts. Yes. So we talk about chemical equation. So who can remind me what is chemical equation? Who can remind what is a chemical equation? Isreen?
There are element symbols and the chemical formula.
Yeah, that represent a chemical reaction. Yes. So we can say that chemical equation is just a group of symbols and formula that represent a chemical reaction. And we said that any chemical equation has two signs. Who can remind me what are the two signs of a chemical equation? Yes, Maya? What are the two? What?
What are they?
What are the two sides of any chemical equation? There is side before the arrow and side after the arrow. What we call them?
The coefficient and the subscript.
No. We said that the chemical equation, once we write a chemical equation, okay, like for example, let's take an example here. So like H2 plus O2, that's going to produce H2O. So here we have that chemical equation. We have two sides. One side before the arrow and the up.
Reactants.
Yes, so reactants and products. Good, okay. So good. We said that reactants, they are the chemical substances that start the chemical reaction. This arrow we call it produces ureals, okay, and the products, they are the chemical substances which are produced, or the new substances that are already produced from the reactants, okay. So like this, that's what we end. Okay, well, that was the end of our lesson last time, and we know what are reactants and what are products. Today, actually, we're gonna pass to very, very important part and interesting part in that lesson. Okay, so let's see here the new part. So we said reactants, they are substances that start chemical reaction. Products, they are the chemicals that end the chemical reaction, or they are the results of the chemical reaction. And we get, okay, this here, how to present. We said that carbon reacts with oxygen to produce carbon dioxide, and we said this arrow is called yields or produces. Now we're going to pass the new part, which is the law of conservation of mass. What is law of conservation of mass? Law of conservation of mass, actually, it's a law that states that mass neither be created or destroyed. That means there is no atom come from nowhere, and there is no atom that could be destroyed or vanished. That means the number of atoms that are involved in the chemical reaction, or the number of atoms which is already found in reactants, must be equal to the number of atoms in products. Okay, guys?
okay.
Yeah. So how could we know that the number of atoms, okay, in and out, they are somehow the same? By the mass, okay? Law of conservation of mass states that the total mass of reactants, for example, if we are gonna, let's imagine here, regarding to this reaction, or let's get, for example, right, we said that Na reacts with, for example, Cl that produces NaCl. Okay, so imagine that we are gonna say that it's 10 gram and the Tl is 10 gram also. So what do you predict? How much the NaCl will be? Yes, Reem? What do you think? Yes, Reem?
Mister, I didn't hear. Can you repeat, please?
Again, we said that if the sodium is 10 gram and chlorine also is 10 gram, so what we expect that the sodium chloride will be? How much it mass? 20 gram, okay? So that's the law of conservation of mass. The total mass of reactants equal the total mass of products. So the total mass of reactants here are 20, so supposed to be 20. Why? Because the number of atoms which are involved in the chemical reaction, they are, or the number of atoms in the reactants must equal the number of atoms in product, because no atom will be destroyed and no atom will just be formed from nowhere. You get the idea, guys?
Yes, mister.
Yep.
Yes.
يعني mister, when you burn a paper, the atoms in the paper, yeah, the mass of the atoms of the paper will
Yes, of
equal
course. The mass of the carbon dioxide and the water vapor and the ash which are produced.
Okay.
They never change. Like that's here. Any chemical reaction, the mass of the reactants must equal that mass of the products. Why? Because simply, as we can see here, mass is conserved because atoms are conserved. There is no atom will be broken down, or there is no atom will just be formed from nowhere. That means I already start the reaction with 10 atoms, so I must end the reaction with 10 atoms. So they are gonna still have the same mass. You get an idea? The only change that happened during the chemical reaction that atoms rearrange. That means, imagine that we are in the classroom and we are 28 in the classroom. Let's imagine that the total mass of you, the entire classroom, about let's say, for example, 300 kilograms or 400 kilograms. Okay. So if we just change your pattern of sitting, okay, or change your shape of sitting, that will affect your mass?
No.
No, it's still the same mass, but you just change your position. So the same that's happening in chemical reaction. We see in chemical reaction, atoms rearrange to form new products, but it's still the same atoms and the same number. So like this, they have the same mass. You get the idea, guys?
Miss, I don't
Yes.
understand.
What? Okay, look with me carefully here, Fadia. Okay.
Mister, I have a question.
Just let me to clarify to Fadia, and if you still have a question, ask it. Okay. Look with me, Fadia. For example, Fadia, let's find a reaction. Let's take the reaction of water. Okay. So we said that hydrogen. That is hydrogen molecule H2. Two atoms are bonded together. Okay. And we have oxygen molecule. That's oxygen. So that's O2. Okay. So they are gonna, what they are gonna produce, or we're gonna find here. So actually we have two of that. So let's get it like this. So what is the first step of any chemical reaction as we studied, Fadia? We are gonna break down
أيوة divide
the
them
bonds.
تقريبا.
We are gonna break down the bonds, yes or no?
Yes.
So atoms will be free. So we have 4 hydrogen atoms which are free now.
4.
Okay, and the 2 oxygen atoms are free, yes or no?
Yes.
So what will happen later? What will happen? Okay, the second step, they will rearrange, yes or no?
أيوة yes.
So as they arrange in that way, each oxygen atom will be bonded with 2 hydrogen to form water, yes or no?
Yes.
Like that. So could you tell me here, okay, how many hydrogen we start with?
4.
And how many hydrogen do we end with?
4 برضه but يعني different
The
orders.
different order. How many oxygen we start with?
2.
And we end by?
2 برضه.
So the number of atoms is still the same. So imagine that therefore hydrogen equal, for example, 10 gram, and this 2 oxygen equal 15 gram. So after the end of the reaction, we still have the same 4 hydrogen with 10 gram and the same 2 oxygen with, okay, 15 gram. Okay, so that means they are gonna equal about 25, and here also 25. Yes or no?
طب
Yes.
مثلا يعني after they're divided وكده they will like form but not like together يعني
Again,
the oxygen and the
again. Sorry, I can't understand your question. Repeat.
I can understand like يعني يعني ماشي okay يعني the oxygen مثلا is divided but like not together.
Yes,
How
divided, that means we set them as atoms, free atoms.
But
yes,
does
are
this
both of
affect
them like
anything
How what?
with the mass?
I can't hear you.
like both both of them are 15 ولا يعني
Both of
together
them,
are...
both of them, the O2, both of them are 15.
Yes, okay.
Okay, you get idea?
Yes, okay.
Yeah. So here like this, okay, we just give example. Actually, they are not the actual masses of them. We're gonna know the actual masses later, but just we give an example that the number of atoms as they are still the same. That imagine, as we said, it's the R here. You are the students, okay, and they sit in that pattern. Then I change your pattern to sit in that way. That will affect your mass?
No,
No, still the same mass, but in different arrangement. Is it hard like this, guys?
no.
So regarding to this, okay, or regarding to this point, okay, once we start to write a chemical equation, the chemical equation must be balanced, okay? So here, like this, let's give here the same idea which I said. Look with me carefully, guys. Here, he make a little experiment. What the little experiment? He got a baking soda and vinegar. Do you know this experiment? Okay, baking soda, like a baking powder, which we use it in making dough and something like this. Okay, and here vinegar. So let's see, that's the represent, okay, the number of atoms of each element. One sodium, one hydrogen, one carbon, and the 3 oxygen. And here 4 hydrogens, 2 carbon, and 6 oxygen. And 2 oxygen. Then once we added them together, okay, they react to produce water, carbon dioxide, and sodium acetate. Okay, they are. If you just count the number of atoms, they are gonna be exactly the same number of atoms which are produced. Yes or no? Let's see how many sodium here. Okay, in the two sides, let's compare one here and one here. Okay, how many hydrogen here? We have 5 in that side, 1 and 4, so they are 5. Here 3 and 2, they are 5. How many carbon do we have? Here we have 3 in that side, and also here we have 3, and so on. So the number only different in arrangement. So that's why once we look to the balance screen, we're gonna say they have the same mass because it's still the same atoms but in different arrangement. Is it clear, guys?
Mister, I have a question.
Yes, of course.
طب هو دلوقتي حصل chemical reaction وكده.
Hmm.
Does the mass increase or decrease ولا
No,
stays
the
the
mass.
same?
No, the mass is still as it is. How the mass could increase or decrease if they still the same atoms but in different arrangement?
My
Guys,
Mister, some evaporated بقى و some went مش عارفة
evaporate.
فين.
Hey, what meaning by evaporated? Even if they evaporated, it's still a matter that I could calculate its mass. Good idea. It's still the water vapor is a matter has a certain mass. You good idea?
طب مستر
Yep.
يعني مستر يعني المفروض if يعني if we put the same ingredients but different in different organizing, it could make a different reaction يعني?
No, it's not like this, guys. Guys, imagine to clarify the idea. It's not about ingredients or not about, we say whatever the chemical reaction that's happened, okay? I got a chemical reaction that has already happened. So the material which are involved, the reactants, the material which start the reaction, they are gonna be the same material or they are gonna be the same atom, but in different arrangement in products, yes or no?
Yes.
So still the same mass. As I said, we are in the classroom, we are 28 sitting in parallel lines. Then we arrange it to make it in a square shape. So does it affect your mass?
No.
No. So the same here, we have in that case, the sodium was attached to 1 hydrogen, 1 carbon, and 3 oxygen. Okay? But once in the result, we find that the sodium is attached to 2 carbon, 3 hydrogen, and 2 oxygen. So they are new arrangement of atoms, but still overall the same number of atoms in reactants and the same number of atoms in products. You got idea?
Oh, yes.
That mean here, let's find, for example, how many, okay, oxygen in that side. Here 3 and here 2. So in reactants, overall in reactants, we have 5 oxygens. Yes or no?
Yes.
Let's find how many they are in products. Here we have 2, 1, and 2. So they still 5. You get idea?
Yes.
So they are the same, but just in different arrangement. That in a state that oxygen was found in 2 substances in that ratio, they are found in 3 substances, but it's still the same number of atoms. So of course they still have the same mass. Is it clear, guys?
Yes.
So the reactant and product must be balanced.
Yes, the reactant, the number of atoms in reactants must equal the number of atoms in products. Okay? Is it clear, guys?
Yes, Mr.
Yes. So that's why here we said regarding to the law of conservation of mass, as mass or the mass must be equal. So we are going to find that the two sides must be equal. Reactants must equal to the products. So this kind of illustrating diagram represent that they are actually equal in mass. Okay, that means the mass of carbon and oxygen, once they are two different elements, they equal to their mass after they combine, okay, in carbon dioxide. So regarding to this, we said in that case the chemical equation must be balanced. What mean by the chemical equation must be balanced? We balance the chemical equation by adding a coefficient. We can understand anything. Let's see here what we are gonna say. Let's look with me carefully, guys. If I wrote this chemical equation, H2 reacts with O2. Let's make this one smaller a little because it's too big too. Okay. That's produce H2O. My question, guys, is this chemical equation balanced?
No.
No. Why? Because here we have two hydrogens and here we have two hydrogen. But here we have two oxygen while here just one. So like this chemical reaction, this chemical equation is not balanced because it seems that one oxygen is lost and that cannot happen. Yes or no, guys?
Yes.
Yes. So this chemical equation is not right. We must balance it to be right chemical equation. So how could we balance a chemical equation? Actually, we balance chemical equation by adding coefficient. Do you remember coefficient which we talked about last time?
The letter?
The big number that we wrote before the chemical substance, okay? So my question, guys, could we change the subscripts? Can we change
No.
subscript? That means could I put 2 here?
No.
No, because subscript is part of the naming or part of the formula, never changes. Changing subscript, it changes the identity. That means actually H2O, that's water, yes or no?
Yes.
But H2O2, that's hydrogen peroxide, another chemical substance. So I cannot put 2 here, okay? So never ever we change subscripts, but we balance by changing coefficient. So how we could balance, let's see. Here we have 2 oxygen, but here 1. So which side need to increase? This side or that side?
This
This one, the water, yes?
Yeah.
So we're gonna add a coefficient 2. So like this, we have 2 oxygen and here 2 oxygen. But here, how many hydrogen do we have now?
2.
No.
2.
No.
4.
4. Remember,
Yeah.
we multiply the coefficient to the subscript. So there are 4 hydrogen, but in that side we just have 2. So what we should do? What we should do, guys?
Hydrogen's 4 and oxygen's 2.
Here, now we have 4 hydrogen, yes, in that side. But in that side, how many hydrogen here?
2.
2. So are the hydrogen, is hydrogen balanced?
No.
No. So what we should do now?
Add 2.
Add 2. Put on coefficient 2 here. So like this, here we have 4 hydrogen, and here we have 4 hydrogen. Here we have 2 oxygen, and here we have 2 oxygen. So overall, the chemical equation is balanced now. You get the idea, guys?
Yes.
Okay. So let's take another example, and everyone please pay attention. Okay. Another example here. So we said that Na plus Cl2, that yields NaCl. So here, guys, let's try to find. So is it this chemical equation is balanced or not? If you know the answer, just raise your hands, guys, okay? Just participate, okay? Because it's very, very important.
Mister, can you repeat the question?
The question, this chemical equation, is it balanced or not? Yes, Hannah Durgham?
No,
No, it's not balanced. Why it's not balanced, Hannah?
because the اللي هو CL يعني it's 2.
Here is 2, yes, but here is
1.
1, so it's not balanced. So how we could balance it? How we could balance it?
Me ولا
Yes, yes, Hannah.
we will 2
So we are gonna add
multiply by 2.
where we should write the 2 beside Na, beside Cl, beside NaCl. Tell me.
لا اللي هو the another one
Here?
اللي هو after the arrow. Yes.
Yeah. So we should write 2 here or here.
لا
A
ده اللي هو
coefficient
CL.
beside the Cl here like this.
Yes.
No.
لا
We
no,
said
no,
never
the script.
change the subscript. Okay. So subscript cannot be changed. Okay. We just use coefficient. So what we should do? We're gonna write 2 here. Yes.
Yes.
Yep. Okay. So like this. So like this now we have 2 chlorine and here 2 chlorine. But after adding this coefficient, how many sodium do we have now? How many sodium here?
2.
2. But in that side we just have
1.
1. So what we should do?
Add
Add 2.
Add 2. So like this. So like this, here we have 2 sodium and here we have 2 sodium. Here we have 2 chlorine and here we have 2 chlorine. It's balanced. Is it clear like this, guys?
So why did the
Yes.
valence be added next to the CL?
Here?
Yes, why?
Because again, we never change subscripts because subscript is part of the identity of the subscript. Like for example, your name is Judy. Could I put a dot above the, or could I just put changing the O with A?
No.
No. So NaCl is a sodium chloride. That's its name. Its formula is NaCl, in which each sodium atom actually is bonded to 1 chlorine. Never they can bond to 2, because actually when we say NaCl like that, it means 1 sodium bonded to 1 chlorine like this. Na is bonded to 1 Cl. But actually, if we said NaCl2, it means 1 sodium is bonded to 2 chlorine. So do you think they are the same?
No.
No. So by adding this 2, you already change the formula, and this actually is wrong because sodium cannot bond with 2 different atoms. It just could bond with 1 only. Good idea?
Yes.
So never we use or we
Mr.
never. Yes.
Why we don't write Na2 with Cl2?
Because you get, so again, Na2Cl2, what does it mean? Actually,
2A
I'm
will
gonna say
join
two.
with.
Listen to me. Actually, we said that the chemical formula must be in the simplest form. So it will be an ACl. You get idea?
Okay.
Must be in simplest form. What the aim if I said Na2Cl2, like when we say, okay, 2 plus 4, okay, that's the same when I say 2, 1 plus 2. Yes or no? That's the simplest form. Good idea?
Yes.
Yep. Okay. So here, like this, guys, the first and the most important thing you must put in your mind, and the goal of our session today, and next time, inshallah, we're gonna practice about balancing chemical equation by making a practice sheet of balancing. We say never ever using subscript. We never change subscript because the changing subscript, it changes the identity of the substance. It make it wrong substance. So we never change the subscript, but we just balance by adding coefficient because coefficient represent the amount of the entire substance. 2 NaCl means that we have 2 NaCl molecules. You get, or 2 NaCl compounds. You get the idea? Like that. So
Yes.
it's represent the quantity, like you have 2 apples, 3 apples, like that. Okay, but I never could use that. It could change the apple itself. You get idea? Is it clear?
Yes.
Yeah. So here, guys, that the part which we need to highly recommend to put in your minds. Okay, and never. Okay. So here we said, look carefully. Only coefficients can be changed when balancing an equation. Okay. We said that the changing subscript changes the identities of the substances that are in the reaction. When no coefficient is present, means it's 1. Okay, so like this. Okay, we're gonna next time know how to balance a chemical equation by practicing more and more. Like this, we end our lesson, guys. So next time, suppose that you are gonna answer the section review or the lesson review in your textbook, and next time we're gonna discuss it, and then we're gonna making kind of practice about balancing chemical equation. So any hard question regarding today's lesson, guys?
No.
No, thank you.
Okay. Thank you, guys. See you next time.